All right, so the last thing we learned is adding and subtracting fractions that have unlike denominators. So we looked at examples like 3 over 4 plus 1 over 3. Okay, and we said, well, these numbers, these denominators, are not the same. So when I draw these, and we used pizzas to draw them, all right, we split them up into their pieces and we colored in, okay, 3 out of 4. So 1, 2, 3 out of 4, and then 1 out of 3. And we said, well, this piece is not the same size as this piece. Okay, they're not the same size, they don't match, therefore we can't put them together because we don't even know how much it would be in total if they're not the same size. So we talked about, well, how can we make them the same number of pieces? And we said, okay, well, what number could we split both of these up so that all the pieces are the same size? And this was one way that we said we used, there's two actual ways that we talked about this. We said we needed a common denominator, okay? We needed that bottom number to be the same. We needed both of these pizzas to have the same amount of pieces. So we counted up by 4s. We have 4, 8, 12, 16, and we count up by 3s, 3, 6, 9, 12, and we looked and we tried to find a number that both of those had in common because that means that we could split these numbers into that many pieces. And we noticed that both of them we can make into 12. Okay, so I can make 4 into 12 evenly. Okay, so let's do that. All right, so I'm going to split this pizza. Instead of having it split into 4 pieces, I split it into 12 pieces. Now, if you notice the colored pieces, now I have 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 12 colored pieces. And my 3 I'm going to split into 12. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. That gives me 12 total pieces. And if you notice, that gives me 4 out of 12 pieces. The red colored region is filling 1, 2, 3, 4 slices. And so now when we add those, now we can actually put them together because the slices are the same size. Both pizzas are split into the same number, slices are the same size. As soon as we do that, we have like denominators. Now we know all we have to do is add up the tops. 9 plus 4 is going to give me 13, and my denominator, that bottom number, is going to stay the same because there's still only 12 pieces in one pizza. Okay? Now we kind of learned, well, there's a little bit of a trick. All right, to being able to solve this. So we said, okay, we wanted to find a common denominator. We need that bottom number to be the same. What if we didn't have the models? Well, we said, okay, I have 3 over 4 plus, actually, let's use different numbers here. So we try a different type of example. 2 over 5 plus 1 over 4, okay? And we said, okay, there's 2 ways you could do this. So you can count up by those numbers, by 4 and 5, to make them the same. So now to figure out that common denominator, all right, we've got 5 and 4. So we could count up by 5s and we could count up by 4s and see what number they both have in common. Okay, so let's do that. 5, 10, 15, 20, 25. All right, and then I'm going to count up by 4s. 4, 8, 12, 16, 20, 24. Okay, and again, if you didn't see a number that both of them had in common, you'd have to keep going, all right? But nice for us that there's actually a number pretty early on that they both have in common, which is 20. So now what that means is that I need to make these bottoms 20. So what do I have to multiply 5 by to give me 20? Well, I have to multiply 5 by 4 to give me 20. And now the thing is, we need to do to the top what we did to the bottom. So if I multiply the bottom by 4, I have to do the same thing to the top. Because if I have my pizza and I split that up into 5 pieces, these are really uneven, okay? And I have 2 of those 5 pieces. And then I'm going to say, okay, well, I'm going to split the rest of the pizza up into 4s. And then I don't include these 2 pieces, well, now the entire pizza is going to be uneven. I have to split everything. So if I'm splitting the whole pizza, I'm splitting up the pieces I've colored in that I have. All right, and then we look at 4 and we go, well, okay, what do I multiply 4 by to give me 20? Well, 4 times 5 gives me 20. What I do to the bottom, I do to the top. 1 times 5. So then what I get is 8 over 20 plus 5 over 20. And now that we have like denominators, we know that all we have to do is we have to add up the tops. We get 13, and the bottom stays the same. That stays as 20. And then the final step would be, can you simplify this anymore? Okay, can you divide the top and the bottom by the same number? Can you create an equivalent fraction that's smaller? So just a reminder for what we did when we were doing equivalent fractions. We had 2 over 4, and we said, okay, what's an equivalent fraction to that? So here we go. We got 2 over 4, and I color in 2 out of those 4. We said, what's an equivalent fraction? Well, okay, if I split it into 2, how many pieces would I need to color in to match, to have the same number, or sorry, same amount of pizza? Well, I'd have to color in 1 out of 2. That means those are equivalent, they're the same amount of pizza. And so one way to figure out how to do it mathematically, to find equivalent fractions, you can multiply the top and the bottom by the same number, and that would give you another equivalent fraction. Now, if I wanted to go down and find an equivalent fraction that's smaller, I would just divide by the same number. 6 divided by 6 is 1, 12 divided by 6 is 2. 1 over 2 is an equivalent fraction to 6 over 12. But if you notice, it's also fully simplified. It's the smallest possible fraction for that amount of pizza. Okay, so if we went up to our number here, we had 13 over 20, we would check to see if could I divide the top and the bottom by the same number. And unfortunately, 13 is a prime number, so you can only divide it by itself, and we can't divide 20 by 13. That's going to give us a decimal. It doesn't work. So 13 over 20 would be our final answer. And now the same thing applies when we're subtracting. If I have 10 over 12 minus 2 over 4, another way we can do this, subtraction is the exact same process, but a trick that we learned in class is instead of having to do this tree and count up by these numbers, what I can do is I can multiply 12 by 4. So I can multiply 12 by that number, and I can multiply 4 by 12. So I multiply this number by that number, and this number by that number. And what I do to the bottom, I have to do to the top, and the same rules apply. We end up getting 40 over 48 minus 24 over 48. And then, now that the bottoms are the same, all we have to do is subtract the tops. 40 minus 24 is going to be 16, and the bottom stays the same, 16 over 48. But the problem with this one is, okay, with that trick, is that we need to simplify. So what can I divide the top and the bottom by? Okay, what number? And the key thing, and that's why we did the divisibility rules, that we realized, okay, these numbers are both even. Well, I can divide top and bottom by 2. I can always divide even numbers by 2. That gives me 8 over 24. All right, and then looking at it now, it's a little bit smaller. Can I divide top and the bottom by the same number again? If you notice, you can actually divide top and bottom by 8. That would give me 1 over 3, and that would actually be our final answer, 1 over 3. All right, and that's the fully simplified answer. And that's the final answer that we would need when we subtract those two fractions. All right, so it's very important that we make what's called a common denominator, okay? And a common denominator means that that bottom number is the same. And then what we do to the bottom, we do to the top. And then we just add or subtract based on how we did it earlier in chapter 6.